students, welcome back. Nice to see you. So students, we have been discussing the chapter rotational motion. Now, we are going to start with the next module of the chapter rotational motion. This module is called as, yes, there you see, numericals based on law of conservation of angular momentum. Now students, already we have discussed one numerical based on law of conservation of angular momentum. Yes or no? Yes. In this module also, we are going to discuss one very important numerical based on law of conservation of angular momentum. So students, it's an important module, an important numerical. Are you ready? Fine. Good. Let's move on. So students, first, let us take a look at the question. Oh yes. It's a very big question. Don't get disappointed. I'm here. Let's solve this. First, let me read the question. Two wheels of moment of inertia 4 kilogram meter square rotate side by side at the rate of 120 rpm and 240 rpm respectively in the opposite directions. If now both the wheels are coupled by means of a weightless shaft so that both the wheels now rotate with a common angular speed, find the new speed of rotation. Okay students, now we have been following a procedure. Yes, we are going to solve this problem step by step. First step is, very good, we are going to write down what are the given quantities. Now students, the question is on, yeah, okay, I know that you are answering, don't get irritated. First, what is the first given quantity? Yes students, two wheels of moment of inertia 4 kilogram meter square rotate side by side. Let me draw the diagram. Two wheels rotating side by side, their moment of inertia is 4 kilogram meter square. Now keep this in your mind. I1 is equal to I2 is equal to I. That means moment of inertia of the first wheel and the moment of inertia of the second wheel both are same. It is 4 kilogram meter square. Fine students. What is next? Yes, it is rotating at a rate of 120 rpm and 240 rpm. So N1 is 120 rpm, N2 is 240 rpm. Okay. Anything else students? Yes. They are rotating in opposite directions. So if one wheel rotates anti-clockwise, the other wheel will rotate in the clockwise direction. Okay. Anything else? Yes, this is very important. Both the wheels are coupled. Coupled means joined by means of a weightless shaft. So I'm going to join both the wheels by means of a weightless shaft. Okay. So this is what is given in the problem. Fine students. Next step. Yes, next step is we need to write down which quantity we need to find. So students, what do we need to calculate? Yes, we need to find out the new speed of rotation and keep this in your mind. The question only it is given. Both the wheels are rotating with a common angular speed. So now both the wheels are rotating with the same or common angular speed. Now rather than saying find the new speed of rotation, I can say we have to find out the new frequency of rotation. And this frequency of rotation is common for both the wheels. Okay, fine. Next step. Yes, next step is formula. And which formula? Yes students, title of this module, Law of Conservation of Angular Momentum. According to Law of Conservation of Angular Momentum, L is equal to I omega, which is equal to constant if external torque is 0. Okay students, so can we move on to the solution? Fine. Let me carry this forward and let me go on to the solution. Now students, first for solution, see the formula. L is equal to I omega, which is equal to constant. That means what? L initial is equal to L final. L initial means it is the total angular momentum of both the wheels before they are joined, and L final is angular momentum of both the wheels after they are joined. Is that clear? So now first let us go to initial, L initial. Now students, both the wheels are rotating separately. Alright, so L1 is the angular momentum of the first wheel, L2 is the angular momentum of the second wheel. So, and remember this, both the wheels are rotating in the opposite direction. And angular momentum is a vector. So L1 and L2 will also be in the opposite direction. So what will be the total initial angular momentum? Total initial angular momentum will be L2 minus L1. This should be equal to L final. Now students, L2 minus L1, we know the formula for L. L is equal to I omega. So L2 will be I2 omega 2 minus I1 omega 1 equals to I dash omega. I dash is the moment of inertia of both the wheels when they are joined together, and omega is the common angular speed. Is that clear? Fine students. After this it's very simple. We know that I1 is equal to I2 is equal to I. So then what will happen? There you will get I omega 2 minus I omega 1 equals to I dash. Now what is I dash? I dash is I plus I, because now the wheels are joined. So then the moment of inertia will become I plus I, which is 2I. So I dash will be 2I into omega. Now students, next step, we know omega. What is omega? Omega is 2 pi n. Also you see that I is common. So let me pull out I common. I'll get omega 2 minus omega 1 is equal to 2i into omega. Now I know what is omega. Omega is 2 pi n. Let me substitute it there. I will get I into 2 pi n 2 minus 2 pi n 1 is equal to 2i into 2 pi n. Alright, n is the common frequency of rotation. Fine. Now students, next step. Next step you see there, 2 pi is common. So let me pull out 2 pi common. You will get I into 2 pi n2 minus n1 is equal to 2i into 2 pi n. Now students, we can cancel out one term. Which term? Yes, we can cancel out 2 pi. So if you cancel 2 pi, you will get I into n2 minus n1 is equal to 2i into n. Alright, now we are coming closer to the answer. Let me carry this forward and I can cancel out which term? Yes, I can cancel out I. So if I cancel out I will get n2 minus n1 is 2n. So what we need to find out? We need to find out n. N is n2 minus n1 upon 2. What is n2? N2 is 240. N1 is 120. So n is 240 minus 120 upon 2, which is nothing but 120 upon 2. So n is equal to 60 rpm. So now both the wheels are rotating with a common frequency of rotation, which is 60 rpm. Students, very big question, but you see the solution. It's very simple. Just we have used the law of conservation of angular momentum. Is that clear, students? So students, it's a very important numerical. Please keep revising it. I'll meet you up in the next module. Until then, remember this. You're all born to win.